Okay, so in this one, some of you simplified right away, and that's okay. Some of you multiplied first, so 2 times 1 is 2, and 3 times 2 is 6. And then 2 over 6 simplifies to what fraction? 1 over 3, good. All right, so a multiplication problem doesn't need a common denominator. Multiplication, and we did learn that last class, but it's confusing when we do both things on the same page. Does not need a common denominator. Questions so far? All right, so Precious, how did you do number 4?
I times both by 2.
So 2 over 2, and that gave you what fraction here?
8 over 10.
Good. All right, so Precious got a common denominator of 10. And your final answer? Oops.
9 over 10.
Yeah. And they have variables in them, so that makes them algebra instead of math 5. All right. The first section says adding and subtracting with a common denominator. So that's a hint that we have a common denominator, but you can see it too, right? So if it has a common denominator, all you have to do is combine the numerators. So I have 6x squared plus 12x over x minus 2. Sometimes I'll be done, and sometimes I won't be done. But one way to know if you are done is to see if there's anything that can factor. So do we have any common factors in our numerator? We do, right? We could factor out what number? 6 and what variable? 6x, right. So we're going to factor out 6x as a common factor. 6x times x would give me the 6x squared, and 6x times 2 will give me the 12x. And here's an x minus 2. Now remember, this x minus 2 is stuck together like that. All right, so I was really hoping I would have an x minus 2 on top so I could cancel those 2 out, but it's not. And so nothing does cancel, but by factoring, I'm now sure that I'm done with the problem. So remember from last class, you can only cancel out if 2 things are being multiplied, because multiplication and division, this fraction bar is division, are inverse operations. Okay? Questions on 1? All right. Try example 2. All right. Let's see how you guys did. I have a common denominator, so I'm just going to bring that down. 6d squared plus 4. And then I'm going to subtract this. So I have 5d squared plus 2 minus 2d squared. And then do I have any like terms I can combine? So in the numerator, I have these both that have d squared, right? I don't know why that looked like a 3, but so I can subtract those 2 and I get 3d squared plus 2, right? You see that? I just subtracted the 5d squared and the 2d squared. All right, in my denominator, can I factor anything out? I can factor a 2 out, right? So I can't cancel anything yet because I don't have a multiplication yet. But if I factor out a 2 from my denominator, 2 times 3d squared gives me the 6d squared. And 2 times 2 gives me the 4. Yeah, you're right. Hi. Yeah. All right. So do you see that? It looked like it was going to be a complicated answer, but it's actually going to be a pretty simple answer, because now that 2 is being multiplied by 3d squared plus 2, I can actually cancel out this part. All right, so this cancels, I have a 2 in the denominator. What's in the numerator?
1.
It is 1. So remember, when you divide something by itself, it makes 1. It doesn't make 0. So 1/2 is your answer. Some of you look like you don't believe me, and that's okay. I just want you to ask a question. You could say, why can't you cancel this out? Or why could you cancel that out? Yes?
Why do you get the parentheses?
So I put the parentheses on the top just to show that I'm holding it together like a whole factor. If I didn't put the parentheses on the top, I could still cancel out the 3d squared plus 2, but it just helps me remember that it's kind of like all stuck together, one factor. Other questions? Okay, I'm going to move on. We have some problems now with not a common denominator. Adding and subtracting, finding the least common denominator. So this is kind of like problem 2 and problem 4 from the warm-up, where we had to find a common denominator. All right, the first thing we want to do in a problem is see if anything can be factored. 7x minus 8, is there anything to factor out of that? No. All right, so let's look at that denominator. It's this one right here. I'm looking for the numbers that multiply to make -8 and add to make 2. Okay, anybody have them? 4, -2. Are those the right numbers? Do they multiply to make -8? And do they add to make 2?
Yeah.
Yes. They just want to let you do the thinking. Okay. So that's factored. So now you can see the second fraction has the x plus 4, right? I'm going to put parentheses on it to keep it together. So the second fraction is missing what factor? It's missing the x minus 2. Okay? So what we're going to do is just like over here when we multiplied by 3/3, we're going to multiply this fraction by x minus 2 over x minus 2. And we're allowed to do that because x minus 2 over x minus 2 is just 1. Anything divided by itself is 1. So you are allowed to multiply by that fraction. One thing that's tricky about a subtraction problem is remembering to distribute it to everything. So here's just a piece of advice. We know that minus is the same as plus negative, right? So if you have a minus, I'm going to suggest that you change it to plus negative. It's just going to be easier to not lose track of your negative sign. You don't have to do that if you don't like it, but you do have to end up with the same answer as me, okay? So minus is the same as plus negative, and it's just going to help you keep track of that negative symbol. All right, I have a common denominator, so I'm going to make one fraction with my common denominator, x plus 4, x minus 2. That's my common denominator. In the numerator, I have 7x minus 8 plus. And I'm going to distribute the -6. -6 times x and -6 times minus 2. So I've got -6x, and negative times negative makes positive 12. Okay, I'm going to pause for a second. If you know what to do, you can continue to combine like terms. But if you're having trouble, you can back up for a moment and process that.
Is it x4?
Okay, so I did forget the plus, but that's x plus 4, x minus 2. I'm going to combine my like terms to get 1x plus 4 over x plus 4 times x minus 2. And isn't that nice when things cancel out? Cancel those out. So I have x minus 2 on the bottom, and what do I have on the top? Good. Any questions? It is possible that the denominator could cancel out, and then you wouldn't have a fraction anymore. So far, we've only had the numerator cancel out, though. But you could make the denominator cancel out. All right, in the next problem, we need to factor these two denominators. Which of these is difference of squares, the first or the second? The first one is difference of squares. Do you guys remember the difference of squares pattern?
Yeah.
No, the difference of squares pattern is that plus minus pattern. Difference of squares. So when we write it, generally we write it with letters a squared minus b squared equals a minus b times a plus b. Okay? So in this case, we have x squared minus 9. We have x squared minus 9, and so x squared is obviously the square of x, and 9 is the square of what number? 3, right. So we would have x minus 3, x plus 3. That's the difference of squares pattern. The second one, though, is not difference of squares. That's just factoring out of what? Yeah, so a common factor, which is x. Okay. So this one factors to be x minus 3 and x plus 3. That's x squared minus 9. This one factors to be x times x minus 3. Okay, guys, we need a common denominator. Hold on one sec. Oh, I see what you're saying. That's your common denominator? Yeah, that's true. So I'm kind of writing it out again because it's messy up here. So I haven't changed anything yet. All I have so far is my factor denominators. I didn't change anything. So both denominators have what factor? X minus 3 is a factor that they both have, okay? This one has an extra factor of x, and this one has an extra factor of x plus 3. So in your common denominator, you're going to need all three of those. Okay? So I need all three of those factors, x plus 3, x minus 3, and the plain x. So this one is missing what in its denominator? X. So I'm going to multiply it times x over x. All right, just like in the warm-up, we can multiply a fraction by 3 over 3. You can multiply by x over x. What is this one missing in its denominator?
X plus 3.
Is she right? Is it x plus 3? Good. So x plus 3 over x plus 3. All right. What I want you to do is keep your denominator factored, but in your numerators, you're going to combine them to see if what you get when you combine all your numerators together, okay? So in the denominator, keep this as one denominator, x minus 3, x plus 3 times x. Out. X times x gives me what? What is it, guys? 2x or x squared? Right. X times x is x squared. Okay. And now I have to multiply this one out. And it's going to take a minute, all right? Because we have to distribute. If you like the word FOIL, that's fine. If you want to make a box, that's fine. Maybe you can fit your box up here somewhere. But we have to multiply x plus 3 times x plus 3. I just distribute. So here's my plus. X times x is x squared. X times 3. 3 times x. And 3 times 3. Okay, so I just multiplied x plus 3 times x plus 3. These problems are tricky because, like, right in the middle of the problem, you're still trying to process how to add and subtract rationals, and all of a sudden you have to multiply two binomials, which in itself is tricky. So they are things that we learned before, but there's just like little pieces in it that are kind of tricky. So I'm going to combine like terms now. I have 2x squared. Yeah. All right, so 2x squared plus 6x plus 9.
Is it a problem if we place the x in front?
So standard form has the x squared first and then the x and then the 9, so that's the best way to write it, but technically it's not wrong when you switch the order of addition. All right, so how do we know if the top is factorable? Okay, so since there's no number that multiplies to 18 and adds to 6, the top is not factorable, which is actually good news because it means we're done. If the top was factorable, we would factor it and see if anything cancels. What's that? And then we're done. Yeah, we would cancel and then we're done. All right, make sure you have that and then turn the page. We have a practice problem at the top. I want you to try your practice problem. You're going to need a common denominator, and then you can combine like terms, okay? Okay, here we go. Please quiet down unless you're ready to share an answer. All right. This denominator is x, this denominator is 3x, so I have to multiply the first fraction by what number? 3 over 3, good. 3 over 3. It does help to kind of put these in parentheses because then it will remind you that this 3 distributes to the x and to the 1. So I have 3x in my denominator, and in my numerator I can distribute the 3 to get 3x plus 3, good. And then plus x minus 3. All right, so you notice that the plus 3 and the minus 3 do what? They do. And then 3x plus 1x gives me how many x? 4. Yeah, for some reason, some of us were subtracting that, and I wasn't even catching that as I walked around. But 3x plus 1x is 4x. I don't know why we were subtracting. Yeah? Yeah. No, it wasn't just you. A lot of us were doing that. All right, and then it kind of looks done, except we forgot to cancel out what? The x. The reason we can cancel out the x this time is because this is 4 times x and 3 times x. And multiplication and division are inverse operations. So then you can cancel and get just 4/3. All right, do you guys want to start the last one together, or do you want to start it on your own? Okay, I'll tell you what, I had both votes. So if you want to start on your own, just close your ears and ignore me. And if you want to start it together, then you can pay attention, okay? All right, let's see what can be factored. Definitely not the 3 or the 4. What about p squared minus 5? Does that factor? Yeah, because it's like almost difference of squares, except that 5 is not a perfect square, right?
Yeah.
All right, this one doesn't factor, but this one does. What common factor can I take out of 2p minus 6? 2. So this is going to be 2 times p minus 3. All right, and now for this one, I need two numbers that multiply to make negative 3. And add to make negative 2. So 1 and 3, which one's going to be negative?
Negative.
1 and negative 3. Yeah, okay.
cancel out the P1?
Well, why do you want to cancel out the P plus 1? Oh, you mean here and here?
Yeah.
So they have those in common, but remember, multiplication and division will cancel. So if I had P plus 1 as a factor up here, I could cancel it. Yeah, but in this case, no.
Okay.
All right. So looking at our denominators, we need to have everything in every denominator. So one of the factors is P minus 3. What's another factor? Yeah, you're right. So I heard one person say the number 2 and another person say P plus 1. So those are the 3 factors. Every denominator is going to need all 3 of those. So let me bring down each fraction. I'm just bringing down my fractions right now and leaving space for the stuff that it's missing. I'm going to change this. It's tricky. Maybe I won't change it yet because I'd have to distribute it to both. I think I will. Guys, pay attention here. See that minus? I'm going to distribute it right now. So I'm going to make this a plus negative here. And when it distributes here, it becomes positive. So that minus, I just distributed it now so I wouldn't forget to do it later. All right, so then I've got plus, oops, I don't want it right there. My bad. Plus negative P squared plus 5 over P plus 1, P minus 3. Okay, so far, all I did was distribute that minus to the P squared minus 5. Now, I need to see what each thing is missing. I'm going to add some parentheses here. So this one is missing the 2 and the P minus 3. All right, so this one's missing the P plus 1. And this one's only missing what factor? The number 2. That's good. Some people have trouble seeing that the number 2 is a factor, but see, since it's being multiplied here, it is definitely a factor. All right. Oh, you can't see that last part. So, keep your denominator factored, but multiply your numerators. All right, so this 3 times 2 gives me what? Should give me 6, right? All right, so this together is 6, and I'm going to distribute the 6 here, and I'm going to get 6p minus 18. I could show that in 2 steps, but I really feel like I don't want to write that much. So 3 times 2 is 6, and then 6p minus 18. Plus the 4 is going to distribute to the P plus 1, 4p plus 4. This is definitely the hardest one. All right, and now the 2 over here distributes to the negative p squared plus 5. So I have negative 2p squared plus 10. That's my numerator. For the denominator, remember you're just writing it one time. And it doesn't really matter what order you write those factors in. I always like to put the 2 there first. Okay, let me pause there for a sec. All right. So when you combine like terms, it's good practice to go in standard form, which means starting with the biggest exponent. So that would be the negative 2b squared, and I don't see anything to combine with that. Is that right? Okay, so negative 2p squared. And now we've got to combine all of our p's. So I have a 6p and a plus 4p, and that's it, right? So I'm getting 10p. And then your constants, which would be negative 18 plus 4 and plus 10. What's that? negative 4, right? Okay. All right, so to find out if this is factorable, I'm going to start by taking out the common factor on the top, which is negative 2. P squared minus 5p plus 2. And now this is actually the easy kind of factoring problem. So I would be looking for numbers that multiply to 2 and add to negative 5. Do those numbers exist? Multiply to 2 and add to negative 5? Morgan is sure they don't. Yeah, they don't. So this is already factored, but I do see something here that can cancel. You see this? The 2 parts can cancel. I will still be left with a negative sign here. So that negative will come down and the 2's will cancel. So remember that when this 2 is multiplied, it can cancel. So bring this over with the negative sign. And then p plus 1, p minus 3. Okay.